It's not every day you encounter an error that completely confounds you, but when you do, it's memorable. Recently, a dedicated member of the Ruby Australia committee, Lee Shepherd, single-handedly rebuilt the Ruby Australia website with a sleek new design using Tailwind 4 and Vite to modernize our asset pipeline. I would highly recommend you all check it out. It is gorgeous. It was a significant undertaking for one person. And as we approached the launch, Lee asked if I could just help him tie up some final loose ends. After quickly addressing an unrelated asset issue, I felt confident my contribution was complete until a mysterious JSON nesting error appeared. At first, I was completely bewildered. JSON encoding errors in the middle of a rendering images seemed impossible. Scoured the codebase for anything remotely related to JSON, but nothing made sense. We chose Vite specifically because it'd proven reliable and straightforward in other projects, so this felt doubly perplexing. Thankfully, our pre-release process involved deploying to a Heroku review apps. Interestingly, this bug only showed up after assets were compiled for production, something we might easily have overlooked if we'd relied solely on local development environments. And so after struggling to reproduce the issue locally, I finally managed to trigger it by running the app in production mode on my machine. The breakthrough, though, came by sheer luck. I noticed the image paths were including strange serialized Ruby object strings. So it dawned on me that Vite was attempting to serialize Ruby objects, causing the bizarre error. Sorry. Then realization struck. The partial I was debugging involved active storage images, which shouldn't be managed. Which should be managed by Rails, not Vite. So swapping out the Vite image tag helper for Rails's built-in image tag immediately resolved that issue. Although relieved and pleased the website could launch smoothly, something still nagged at me. Why exactly had Vite triggered this serialization? This lingering curiosity prompted me to investigate further. Diving into Vite Ruby's internals, I discovered the library attempts to generate helpful error messages when assets aren't found, doing so by JSON encoding its asset manifest. Our Vite configuration inadvertently had created a circular reference in the manifest, causing the serialization, and thus the confusing JSON error. Reflecting on the experience has reinforced a valuable lesson. Sometimes attempts at providing helpful debugging information can unintentionally obscure the real problem. As developers, we must carefully design not only our core functionality, but also how our system communicates failures to those using them. And this experience led directly to today's talk: understanding and clearly communicating intent through code, and respecting the boundaries and implicit contracts within our system. In software development, every line of code embodies implicit assumptions, unspoken agreements between different parts of a system. These unspoken contracts dictate how components interact, setting expectations for data types, formats, and responsibilities. When these contracts remain implicit or undocumented, they become a breeding ground for subtle, confusing bugs. The issue I'd faced with Vite and active storage highlights exactly how these invisible agreements can break down. We implicitly assumed that all image handling could transition smoothly to Vite. ignoring the distinct boundary separating Rails-managed assets from Vite-managed ones. This implicit assumption wasn't malicious or careless. Rather, it's a natural oversight made possible by a lack of explicit boundaries. Such situations aren't rare. They happen frequently during refactors, migrations, system integrations, especially when technologies and frameworks coexist. Without clear communication of intent, the potential for misunderstanding grows dramatically. As developers, our goal should be to make these contracts explicit, to communicate it clearly through naming, documentation, and structured boundaries. Doing so reduces confusion, improves maintainability, and significantly shortens debugging cycles. So we've established that unspoken contracts are a common and dangerous source of bugs. Now let's look at some concrete ways to communicate clearly through our code, documentation, and structure. By taking intentional steps to make implicit assumptions explicit, we create software that's easier to understand, debug, and maintain. Naming is one of the simplest yet most powerful ways we can communicate intent. Good names make implicit assumptions clear. Poor names obscure and confuse. When we face our issue with Vite and active storage, the confusion stemmed partly from the naming of helpers. The helper Vite image tag seemed logically interchangeable with image tag, but it wasn't. The implicit assumption that both helpers could manage all image assets equally caused significant confusion. To avoid this, choose descriptive, specific names that communicate exactly what a piece of code does. Differentiate clearly when similar looking components have fundamentally different roles or responsibilities. Explicit naming is often the simplest yet most impactful improvement you can make. It's the first line of defense against ambiguity. And of course, that's easier to say than to do. In the context of this incident, there is no clear place to put this information. Like, should Rails, the docs carry a warning? Should you put the comment in the Rails partial? But like, a brief note in the partial might have made me immediately realize that something was amiss when seeing Vite image tag. Good documentation and comments explicitly state these kinds of assumptions and guide developers away from accidental misuses. Consider adopting these practices. Inline comments clearly state unusual or critical assumptions right where developers will see them. And I know comments can be a dirty word in these parts, but while I agree that code should aim to be self-documenting, there are just some things that can't be conveyed in method names alone. Documentation blocks. While I like my code to self-document inputs, interfaces, and outputs, I like documentation to explain anything that isn't obvious. That could be why the class or method works the way it does, any unexpected surprises to watch out for, or detail about the boundary points between the interfaces. Then there's project level documentation. When integrating new technologies like Vite, clearly document how and where these tools are expected to be used. Include examples and highlight potential pitfalls. Software systems inevitably consist of multiple interacting parts, often using different frameworks, libraries, or even different programming paradigms. Clearly defined and documented boundaries help ensure assumptions remain explicit. In our situation, the boundary between Rails managed assets and Vite managed assets was unclear. The resulting confusion led directly to our error. A clearer interface would have prevented this entirely. Practically, this means clearly define integration points, explicitly state what each system or component is responsible for, and what data they expect. Avoid mixing responsibilities. Each component or tool should have clearly defined ownership. Avoid situations where multiple tools attempt to manage the same data or process. Guard against accidental usage. Use structures such as namespaces, helper modules, or dedicated directories to reinforce the intended boundaries visually or structurally. A strong boundary acts like a contract, clearly communicating who's responsible for what, preventing subtle bugs, and making integrations easier to maintain over time. Explicit communication through naming, documentation, and structure is important, but thorough and strategic testing is equally essential. Tests specifically designed to validate your explicit contracts can catch violations early, often before code even reaches production. In the example of our confusing Vite error, the issue was subtle enough that it slipped through standard development workflows. It only appeared when assets were compiled in production. In our case, it was testing in a production-like environment that caught this issue before production. Even if your commercial application doesn't get comprehensively tested pre-production, it would still be possible to test the integration in CI. To create robust boundary tests, simulate production environments as closely as possible. Run critical integration tests in environments closely matching your production settings, especially when involving asset compilation, database connections, or external services. Explicitly test integration points and assumptions. Write tests specifically for the integration points between major parts of your application. Continuously revisit and refine tests. As your application evolves, periodically revisit these tests to ensure they remain relevant, accurate, and comprehensive. These strategies, intentional naming, structured documentation, clear boundaries, and robust testing, collectively form a strong foundation for explicitly communicating intent. They prevent the kind of subtle, painful bugs we encountered and make our software easier and safer to maintain. In practice, adopting these strategies is not about creating excessive overhead or documentation. Rather, it's about making small, intentional, and strategic changes that pay off dramatically in clarity and maintainability. It helps your team avoid the kinds of confusion we experience and ultimately saves considerable debugging and development time in the long run. Clear communication of intent extends beyond code alone. It involves effective collaboration among team members. Even perfectly named methods and well-documented code won't prevent issues if team members are unaware of underlying assumptions or changes. Provide detailed context in pull requests. Explain not just what changes were made, but why they were made. Highlight any important assumptions or potential side effects explicitly. Write commit messages that clearly state the purpose and scope of changes. Think of commit messages as your conversation with your future self or teammates. Explicitly call out changes affecting system boundaries during team meetings and code reviews. Encourage reviewers to challenge implicit assumptions and clarify intent proactively. Maintain documentation capturing significant architectural decisions and boundary definitions. Keep these documents accessible and regularly updated. Encourage a team culture where asking clarifying questions is welcomed. Reward clear and thorough communication, recognizing its role in reducing confusion and maintaining quality. Effective communication isn't just about avoiding bugs, it's about creating a collaborative environment where every team member clearly understands how their work connects to the bigger picture. By fostering clarity and intentionality across both code and communication, we build resilient systems and cohesive teams. As we reflect on the JSON nesting era, and its subtle but impactful cause. We're reminded that the most significant bugs often come not from complex logic, but from unclear expectations. Our software becomes stronger when we shift from implicit assumptions to explicit communication, both within our code and across our teams. Clear communication and intentional boundaries don't just reduce bugs. They build a culture of confidence, trust, and efficiency. This week, or I guess given it's Thursday, maybe next week, I challenge each of you to examine your own code base. Identify one area where the intent is unclear, the boundaries are blurred, or assumptions remain undocumented. Take a moment to clarify that area. Write a comment, improve naming, or document a critical interface. This small step will significantly improve the maintainability and reliability of your software. Ruby Australia is a volunteer organization, and I want to take a moment to acknowledge everyone who contributes to this amazing community. The star of this particular story was Lee Shepherd, who put in an incredible amount of work to build a beautiful professionals website that reflects the breadth of what Ruby Australia does. But there are many names in the commit log, ranging from experienced engineers like Lee to people who are just getting started with Ruby. And there are a lot of generous people who give up their time to make all of this possible. This meetup, for example, wouldn't happen without our sponsors. And while we have our own drink sponsor, Gleam.io, the broader sponsorship efforts are managed by the Ruby Australia Committee, and we have a treasurer who makes sure that the organization stays solvent and compliant. It's hard to overstate the work that goes into events like conferences, retreats, Rails Girls. My God, you should see the sheer volume of documentation the secretary handles. On a personal note, I couldn't run this meetup without Sim. Even when he's not here in person, he's still chasing down speakers and sorting out catering behind the scenes. There's Justin Tan, who edits the videos of these talks. I barely have to think about it. Like magic, professional quality recordings just appear on YouTube. And right now, we're obviously super excited about our new venue and the upcoming rebrand. That's being led by Huli, who's brought his infectious enthusiasm to help us bring us back to the big time. So I'd like to take a moment to thank everyone who makes this community thrive. To quote a recent post from our president, Nick Wolf, whether you're brand new to our community or a long-time member since the very first camp 15 years ago, we'd love to hear from you. From running large events like RubyConf AU or Ruby Retreat to mentoring, supporting local meetups, helping with Rails Girls, contributing technically or administratively behind the scenes, we're keen for your help. So if you're interested, please reach out to the committee. But before we move on to the next segment, I wonder if anyone else has a relatable story or just a question. Yes, Michael, of course.
I mean, I had one today, right? So I'm at a new place, Node.js-ish, and it was GitHub deploys all the way, and I get this completely other story why I create 4 different ERs on 4 different branches. But all of a sudden, I noticed that the build block blows up, and I'm like, oh shit, what have I broken? You know, I've only been there for a month. And I look and it's the Slack message integration. So it's actually deployed. It's just the Slack message was crashed. And it's crashed because they've decided in their Slack message to just grep the last commit and throw that into Slack. And based on what you've said, I am very much documenting in my commits. So I had multi-line, I had like cleaned up lit, and then multi-line of what I did, the sed and awk scripts I ran. And obviously there was some escape characters in there and there was no attempt even to clean them out. But in this case, it ended up breaking the build. Well, it didn't break the build because it actually deployed, it just broke the Slack message at the end. But it got, as you were saying this, it kind of did remind me of today's problem.
Yeah, I must confess, it did occur to me that like if you're going to create if you're trying to create helpful messages, make sure you don't create an error in the error message. Right. Yes, Brendan.
Were there any changes that could have been made? Did you make a PR against the library?
I haven't. I must confess, I investigated this last night so I could write this talk. So no. I started the PR and then I realized I need to think more deeply about exactly what we should do about it. But I think the answer is if if we think that it's valuable uh to dump the manifest, maybe just make sure that there is a rescue on that. But it seems like a conversation that probably needs to be had with them before I just send up a PR. Mm.
Or maybe a couple of comments or things that I've found that helped me in the past.
Mm.
In similar situations, using utilizing atomic commits. So if it's that really just do one thing, then you do get like a huge commit. But you can then leverage tooling like Git bicep to identify where the defect was introduced. Yeah, like JSON parsing errors be notoriously difficult to identify. But yeah, the interesting something that sort of clicked me was that by manifest probably you should never expect to have Ruby objects passed into them. So having some sort of like parser before, like in that sort of service boundary, you know, I think that's gem, but you could at least then go, hang on, we're sending the wrong thing. You know, in the absence of strongly typed environment, you can introduce to sort of parsing at the service boundary edges to give you that confidence.
Absolutely.
This is all more work than like well thrown out.
Yeah. I do think if you're building something that's as foundational as say a Vite library, you probably should be considering these things.
Absolutely.
Like, I can understand.
Yes.
Yeah, because obviously to even answer find out where this was, I sort of had to dig down into their library code. And I think there's probably a lot of people who wouldn't even know to do that, let alone know how to debug the problem.
About the confidence for that.
True. Yeah.
That's it. Like with the JSON parsing array, you like the stack trace, if you can actually find it, the server looks, it will have like the line reference for the JSON payload, which is going to be meaningless. Then you're not going to be able to like recreate that access because it's just going to be confusing. It's going to be misdirecting you from the actual call site.
I must confess, the first time I looked at the manifest, I don't think I've ever seen what a circular reference looks like in a hash. And it was just like square brackets and 3 dots, and I was like, oh.
Is that if you do expect
Yeah, I guess so. Yeah, yeah. Yeah, exactly. I think if I remember correctly, I put in a debugger line and then just, yeah, typed manifest into the console. Which was yeah, it was interesting. So yes.
Yeah, to say like another comment thing. Just things that work for me. Like the first part of the talk about comments and documentation. I try to follow this rule sort of like minimize comments or aim for 0 comments, like all says comments. So I might like look at a piece of code and say this is really hard to understand, so I'll try the refactoring. Let's rename the variable. Is that good enough? Sometimes it's not. Okay, now I need a private method. Is that good enough? Maybe not, then I'll extract class. You know, maybe half the time that's enough to avoid the comment. And then I kind of find that the vast majority of comments are the like architectural things, or like I need to pad this string with zeros because the API will break from it. And there's really no good way to express that in methods, like maybe.
It'd be pretty weird if your method name was like removing this because the API doesn't like it.
Yeah, I don't know. That's how I find them. Minimize comments and comments out.
Yeah, absolutely.
On that, you've documenting architectural decisions or decisions or even technical discoveries, and having those in Repo can be really beneficial. Something that both your comments reminded me of is having having a well-written test around the intention of your code, the test subject, trumps comments to me any day.
his comment also, your comment reminds me of the case principle, right? Keep it simple.
Mm-hmm.
Luckily, I haven't done this in Ruby, but in Python, it's easy to do because of its list and dictionary comprehension. And sometimes a beautiful, albeit rather complex code is not the way to go. And I had once, I was using an external financial service data for certain simulated experiments, and they would, instead of providing JSON, they would provide CSV.
Okay.
I thought that was common. Yeah, no,
Just the time. It was right with the 10 version.
what was that?
Ah, it's not Excel. Yeah.
No. Oh.
XLS.
So, yeah, I had that risk with a warehousing company. I'm going back there. They were providing XLSX file. Anyway, so yeah, they were providing CSV instead of JSON. So I decided, well, I can do something very complicated. I need JSON structure. So Python has dictionary comprehension, absolutely amazing. And I decided to go 3 levels deep. So it was a single liner, so to speak. Dictionary comprehension, absolutely beautiful code, didn't require any methods. Went back to it just a week later. I said, what the F have I done here? And I did write comments. This is what it's doing. This is what it's doing. It took me another 2 days to just understand my own code. So beautiful code. Ruby allows you to do it right there as well. Sometimes it may be very complicated and absolutely amazing piece of code, but hard to pass down the line. And that's dead.
Yeah. You actually reminded me, one place that I do use comments regularly is when I'm doing anything that's not just a really simple regular expression. I love using the Ruby's ability to put it over multiple lines with comments and then just comment like every subsection of the regex. There's nothing worse than trying to remember what the hell you were doing in a regular expression.
Yeah.
What's you mean a multi-line?
I think you pop an X at the end. So you do the percent R, open the braces, and then at the end you chuck an X, and then you can just put the regex over multiple lines, but it treats it as if it was one line. And then you can just chuck comments after each line. It's very nice. Very, very nice. Any final trauma before we wrap up? No. Someone on Zoom? Hang on. Oh, sorry. Unfortunately, I can't actually see the Zoom chat anymore. So Lee says, I think in teams where developers do not have the support of a DevOps person, commenting on infrastructure is important so it reduces cognitive load. And I could not possibly agree with that statement anymore. Particularly as someone who barely understands DevOps. All right, well, thank you so much, everyone. Oh, sorry, there's one more. Sorry.
Earlier when I started working
Yeah.
for the project, there was some, I think, 404 error, and they use a lot of hooks and caching is just like not. I mean, this is like connecting. It is not like the components are like connected in a very weird manner. It's so difficult to debug. So that's really a trauma for me trying to do something like that. And speaking about DevOps as well, like when you're, I think in development, when you're writing the code, you don't come across any error, but when you deploy it when you deploy it on your like via GitHub Actions onto the main branch, I think the way Terraform was configured, as a result of that, while deployment, it suddenly throws you errors in. And I think I don't remember exactly what particular error it is. I think, yeah, I mean, changing that required me to make a lot of other changes. Quite difficult.
Man, you're bringing up my trauma. All right, thanks so much, everyone. Appreciate it.